The average income in a certain region in 2013 was $74,000 per person per year. Suppose the standard deviation is 29,000 and the distribution is right skewed, so technically not a normal distribution. Suppose we take a random sample of 100 residents of the region, and part A says, is the sample size large enough to use the central limit theorem for means? And the answer to that is yes. Here we have 100 residents, and for this theorem to apply, we have to have more than 25. So that looks like it's B. So I'll select that one. Okay, once you go past 25, then the distribution for the means becomes normal, meaning you can use a normal distribution. Now the mean for this sampling distribution is going to equal the mean for the distribution here, which is $74,000. So those two things are the same. The mean here is the same as the value here. Now for the standard error, that's going to be different. So this is the standard deviation for the sample from here. But to get the standard error for the new distribution, you take this value and divide it by the square root of this value. So basically you just divide this number by 10. Just to see it on a calculator, just in case you come across a number that doesn't have a nice square root, the process would be you take the original standard deviation, which is 29,000, and you divide by. Now, to first get the square root of a number on a calculator like this, you would open a parenthesis, you type in the number that you want to take the square root of, then you click the square root button. This number still hasn't been divided into the original number, but if you close the parentheses and then press equal, well, then it divides it into the first number that you entered. So, no surprise, this divided by 10 is 2,900. Check my answer. Okay. Now we want a probability. In fact, what is the probability that the sample mean will be more than $2,900 away from the population mean? Now the wording of this is interesting. More would make me think like above this number, but this, here, this away means we could be more than $2,900 away from the mean in two directions, above or below. So this away makes me think we're actually going on two sides of the mean. I'm going to use the calculator in StatCrunch to figure this value out. So I'm opening up StatCrunch, and I'm going to use the normal calculator. So here I'll go to, okay, it's not showing up on the screen. Let me just open this a little bit more. So stat, calculators, here it is, normal. All right, because the mean for the sampling distributions is normal, I'm going to put the mean here. That was $74,000. And the standard deviation is 2,900. I don't think there is an option for being like less than and greater than at the same time. So I'm going to switch this to just greater than for now. And it says to be more than $2,900 away from this mean. So that means, pull up my calculator here, if the mean is $74,000 and we're more than $2,900 away from it, we would add 2,900. Okay, so this is the value that I want to put here. That's $76,900. So I can close this, and I'll click compute. So here's the middle of the data, which is $74,000, and this is more than $2,900 above the mean going in this direction, and we get this value. So the number I get, if I round to 4 decimal places, is 0.1587. But we have to account for the fact that, well, we could be on this side of the mean and below. It'll be symmetric to the area that we have here. So basically what I'm going to do is take this number and double it. So I'm going to do that in my calculator. I'm going to type this whole thing in and multiply it by 2 so I can account for the area that should be down here as well. So actually, let me pull the calculator back up. So I'm going to take the probability that was 0.158655525, and I'm going to double it. Okay, this is the probability that we're looking for. Rounded to 4 places, it's 0.3173. Okay, I'll check my answer. All right, so that is it for this problem. And just to point out that more didn't mean just greater than because of this term here, away. That meant you could be either above, but also on the other side, below, which is why I doubled the value that I got from the calculator.